Okay, so another example using the 68, 95, 99.7 rule would be this. So vending machines can be adjusted to reject coins above and below certain weights. The weights of legal U.S. quarters have a normal distribution with a mean of 5.67 grams and a standard deviation of 0.07 grams. If a vending machine is adjusted to reject quarters that weigh more than 5.81 grams and less than 5.53 grams, what percentage of legal quarters will be rejected by the machine? So the first thing I need to do is I want to draw my normal distribution, right? We've got our mean in the center. I'm going to go up 1, 2, 3 standard deviations. And I want to go 3 standard deviations below the mean as well. So 5.67 plus a standard deviation is going to give me 5.74. 5.74 plus 0.07 is 5.81. And I get 5.88 for my third standard deviation. Now, below the mean, I'm going to be subtracting. So 5.67 minus 0.07 is just going to be 5.6. I do that again, I get 5.53 and 5.46. So let's take a look at the data values we're given. We say our vending machine is going to reject quarters that weigh more than 5.81. So here's 5.81, so it's going to reject all the quarters over here. And it's going to reject quarters that weigh less than 5.53, so that's all the quarters over here. So this is within 2 standard deviations of the mean. How much data is within 2 standard deviations of the mean? Well, our 68, 95, 99.7 rule says that 95% of the data is within the first 2 standard deviations of the mean, meaning the area under this portion of our curve is 0.95. Okay, that's great. That's the coins that are going to be accepted, but I want to know what percentage are going to be rejected. So I have to take my total area, which is 1, or 100%, minus 0.95, and then I'll be able to find out how much is the area in these wings. Well, I get 0.05. So the sum of the area in both these little tails, they call them tails, is going to be 0.05. So 5% of quarters will be rejected. Let's go through another example. The first thing I want us to talk about, though, is identifying unusual results. These are often also called outliers. But in statistics, we often need to distinguish values that are typical or really unusual from values that are usual. And what we do is we say that usual values are values that are unusual values are values that are more than 2 standard deviations away from the mean, right? Since within 2 standard deviations of the mean, we have 95% of the data, right? We have the majority of the data. So that's how we'd identify unusual results or outliers. Let's go through a couple more examples using the 68, 95, 99.7 rule. So pulse rates of adult females are normally distributed with a mean of 74 beats per minute and a standard deviation of 12.5 beats per minute. What is the percentage of adult females with pulse rates below 49 beats per minute? Let's go ahead and draw a lovely normal distribution. I've got a mean of 74. I want to go 1, 2, 3 standard deviations above the mean. And I'm also going to go 1, 2, 3 standard deviations below the mean. So 74 plus 1 standard deviation would be 74 plus 12.5. So I get 86.5. I then get 99 and 111.5. Next, I need to go standard deviations below the mean. 74 minus 12.5 gives me 61.5, 49, and 36.5. So I want to know what's the percentage of adult females with pulse rates below 49 beats per minute. Let's use green. I think that shows it better. So 49 marks the second standard deviation. I want to know what percentage of values are over here. Well, within the second standard deviation, I know I have 95% of the data values, so the area right here is 0.95. I also know that the normal distribution is symmetrical. So if I took 1 minus 0.95, I get 0.05. But that's the area in this tail and in this tail. And I just want to know the area over here, so I can divide it in half because it's symmetrical. That means that the area in this tail is 0.025. So what percentage would be? Would be 2.5% would be our final answer.